Well, that's good. It's good not to die. All right. I don't know. It's weird, huh? Yeah, you just start breathing again. Okay, we're going to do limits by graphing. Yeah, limits by graphing, you know, it's a little cheater way of doing it. You're going to need your graphing calculator, so make sure you get that out. Yeah, you'll have your calculators this quiz, but some of them I'll say, you know, solve by algebraic means, which means I need to see your work. You can check your answer if you want to by graphing, but if I say algebraically, you must do it algebraically. Okay, so as x is getting closer to c, what value is f of x approaching? That's the thing that we're going to do. That's limits. So we're not really finding what the y value is. We want to see what it's approaching. So we're going to do some limits by graphing. Here we go. So graph. You do not need to draw the graph. You just need to give me the answer. Sometimes it's nice. There's no partial credit on these, though, because they're pretty much right or wrong. So number 1. Let's find the limit as x approaches 0 for the sine of x divided by x. All right, this would be pretty tough to do algebraically, because what would you do? There's nothing to FOIL, there's nothing to factor, there's nothing to reduce. And you look at this and you think, all right, well, let's go ahead and graph it. So graph this one on your calculator, because obviously if you use direct substitution, you're going to get 0 over 0, which doesn't mean that the answer is 0, it just means that there's something else to be done. So you go to graph it, and we're going to do sine x divided by x. You can hit zoom trig if you want, or zoom 6, it doesn't matter. Okay, and as x is approaching 0 from both sides, we want to find out what y is getting closer and closer to. So if I hit trace and I plug in x is 0 on my calculator, I get nothing for y because it's undefined there. Make sure that you're in radian mode, and then make sure that you close the parenthesis on the x and then hit divided by x.
I did. I was in the wrong mode.
And then hit zoom 7. I hit zoom 7.
I'm getting so tired. I'm gonna make a shit.
Let me see.
Did you set y2 equals 0?
I did on accident.
Oh, you don't need to.
No, you're fine.
If it zooms out.
Yeah. I hit zoom 7 for you, zoom trig. Okay. Now, a nice way to do this is to check out what y is on either side of x is 0. So I can plug in, I can hit trace and plug in 0.0001, and it says that y is 1. I can plug in negative 0.0001, that's on the other side, and I get y is 1. Okay? So, you know, it's not algebraic, we're not proving it, but what we're doing is we're just kind of showing that the limit is 1 graphically. Okay? Doesn't
That way we don't have to draw it.
we don't. It doesn't equal 1 there. There's a hole in the graph. But as we're approaching 0, see this is x is 0 right here. As we're approaching 0 from both sides, it gets closer and closer to 1. Yep, zeroing in on a number. All right, number 2. Let's do another one. Yeah. Let's do the limit as x approaches 3 for x squared minus 9 over x minus 3. What, is it cold in here?
Yes.
Turn it up then. If you don't like it, fix it.
Put a sweater on.
I don't have a sweater.
Well,
He was already wearing long sleeves and he's cold.
Thanks, Molly.
See how thin this is?
Okay, for this one right here, I would, if I had a choice, I would just solve this algebraically. I'd factor the numerator, reduce, and plug in. But this says to solve graphically, so let's see what it looks like graphically. So let's go ahead and graph x squared minus 9 divided by x minus 3. And I'm going to hit zoom 6 this time. Okay, and it looks like a line, which you probably weren't expecting, or maybe you were. It is a line with a hole in it. So if I hit trace and I want to see when x is getting closer and closer to 3, what's y approaching? Y is nothing there. It doesn't equal anything. But on either side of 3, like 3.0001, yeah, do you do that? You just go left and right of 3. That's perfect. I get y equals 6. If I do 2.99999, I get y is 5.99999. So they're both coming in closer and closer, and the answer is 6. Okay? And maybe you're like, oh, graphing's easy, but I kind of think it's like almost like a guess. You're trying to zero in on something. What if that was really 6.1 was the answer? That would be really hard to tell. I'd rather solve that algebraically. Factor the top, reduce, plug 3 in, you get x plus 3, and you get 3 plus 3 is 6. So, okay, let's do 2 more of these. So number 3, the limit as x approaches 0 for 1 over x squared. Now this is a little different because the last ones that we've done, we plug in the number and we get 0 over 0. You don't get 0 over 0 here, do you? You get 1 over 0, which is undefined, but that does not mean that the limit doesn't exist. Let's take a look at this one. If you were to graph this one, it looks like this. Kind of reminds me of the Atari symbol for some reason. All right. You guys don't know what Atari is, huh?
Yeah, we do.
Oh, you do? Okay. So it goes like that, okay? And so as x is going this way on our graph, our y is getting closer and closer to infinity. As x is going that way towards 0, our y is still getting closer and closer to infinity. So the limit, as our book says, the limit is infinity.
Well, there are 2 x's probably.
No. Right, there's always only one. Now, let's change that last problem to be the limit as x approaches 0 for 1 over x. Okay? And you think, oh, it's just like the last one. I get 1 over 0, and so my answer is going to be 0. But that's not true. For this one, the graph looks like this.
That's what I meant.
Yeah. So as I'm approaching this, x is 0 from the right side, my limit is infinity. But as I'm approaching x is 0, as I'm getting closer and closer to x is 0, I get negative infinity. Well, you can't be both positive and negative infinity at the same time. So when your answers don't match up, when they're not approaching the same value, we say the limit does not exist. D and E. The limit does not exist. Mean Girls, right? This is such a good movie. All right. It was, Trevor. You lie. All right. So that brings us to part B, which is our second and last part of the day. We're going to talk about two-sided limits. No. Nope. Two-sided limits. All right. In your book, you have a theorem. It's called Theorem 3. It really is. Theorem number 3. You don't need to know what the number is. But this is what it says. This theorem says that a function f of x has a limit as x goes to c if and only if. This is how we abbreviate if and only if. If is different than if and only if. If goes one way. This, or, if that. But if and only if means I can go that way and I can come back this way, too. Both ways work, okay? So a function f of x has a limit as x approaches c if and only if right and left limits at C exist and are equal. Both exist and are equal. That is a theorem. It's a very important theorem in calculus. Calculus, you're going to learn a whole bunch of theorems. If you want to take Calc 1, 2, 3, which is Calc A, B, B, C, and then you take Calc 3 in college, you learn all these theorems, and then when you take analysis or advanced calculus, that's all the proving of them. I got a C in that class. It was hard. Okay. Anyways, really hard class. No, advanced calculus. I didn't get C's in any of Calc 1, 2, or 3, so don't even say that. All right, so here we go. This is what it's saying. The limit as x approaches C for f of x is equal to L, then this will be true, and it goes both ways. The arrow goes both ways, okay? The limit as x approaches c from the right, c plus, you know, that grade some of you guys are getting in here, of f of x equals L, and, it's so rude, huh? And, I don't think anyone's getting a C in here. The limit as x approaches c minus, so that's the grade some of you guys are getting here, of f of x equals L. Okay? What that's saying is the limit is L if and only if on the right side it's L and on the left side it's also L. They have to be the same, okay? So we're going to do a problem here. So
Does that go with number
yeah,
3?
yeah. Number 4? 3.
5. Oh, and it-
This one? Yeah, so this one had a right-hand limit of infinity and a left-hand limit of negative infinity. They weren't equal to each other, so the limit did not exist there. Okay? That's why I always say, oh, you got to go in from this way, you got to go in from this way, right? That's why I was doing 2.999 or 3.001. They have to be from both sides. All right, so number 5, here we go. I want you to draw this graph as best you can. Okay, it's a little weird. It's a really strange piecewise graph. So bear with me. Here we go. 1 and 2, and then 4. 1, 2, 3, 4. All right, go ahead and put a dot at 0, 1, and an open circle at 1, 0, and draw a line there. And then at 1, 1, put a dot, and then an open circle at 2, 1, a line there. And then go to 3, down to 4, put a solid dot at 4, and then put a solid dot right there. Whew. All right, so draw that as best you can. Okay, kind of a weird graph, lots of breaks in it. And we're going to do like a whole bunch of problems for this graph, okay? So that we can see what left and right hand limits are all about. I'll let you catch up. Okay, so let's go ahead and look at as x approaches 1. So we're going to call this function y equals f of x. Okay, it's a piecewise function. I don't even know what the equation is, it doesn't even matter. So I want to find the limit as x approaches 1 plus of this function. Okay, then I'm going to find the limit as x approaches 1 minus of the function. Now, if you've done these before, don't shout it out, because some of you guys have done these before, so it's not going to be that bad for you. But others, if you haven't done this yet, it's a little tricky at first. Okay?
Answers need to be the same.
No.
They can be different.
Yes. Yeah. So this right here is asking you to find the limit as x approaches 1 from the right side of 1. Only from the right side. That's what plus is. The minus is from the left side. So here we go. I'm going to jump on my graph, and I'm going to approach 1. Here's 1 from the right side. And what is my value getting closer and closer to for y? It's getting closer and closer to 1. Okay? You jump on the graph, and you approach x is 1, and the y value is actually 1 there. Now, let's go on the left side. I'm going to go from the left side of 1, which is over here, and what is my y value getting closer and closer to? 0. Okay? Now, we say then that the limit as x approaches 1 for f of x what? Perfect. Does not exist. They have to be equal to each other. When I'm approaching my value of x is c, my y's can't be different. I mean, they can. If they are different, then it does not exist. So there is a right-hand limit. It's 1. There is a left-hand limit. It's 0. These did not match up. Therefore, the limit does not exist at 1. Okay, let's try another one. Let's do the limit as x approaches 2 plus and 2 minus and the limit at 2. Okay, now remember what a limit is. So 2 plus, 2 minus, and 2. It's, yeah, that dot's there to mess with you. Remember, we don't care what happens at 2. You don't care. You're looking at what your y value is getting closer and closer to, okay? So let's go ahead and jump on this graph. As I'm approaching 2 from the right, my y value is getting closer and closer to what? 1. It's not getting closer and closer to 2, okay? Picture yourself walking on that line, and you're going towards 2 from the right-hand side. My y value is approaching 1. Okay? Go on the other side of 2 now. Walk towards 2 from the left. You walk towards 2 from the left, your y value is approaching 1 again. Okay? So then the limit, as x approaches 2, since they are equal to each other, the limit is 1. Now here's kind of the follow-up question. What is f of 2 on my graph? When x is 2, y is 2. It wasn't the limit. It doesn't have to be. The value there's 2, but the limit's not.
Would that be the dot?
Yeah, that's where the dot is. Okay. Was that all for that one? Oh, one more of these. What's the limit as x approaches 0 plus? And what's the limit as x approaches 0 minus? Yeah. Yeah. So as I'm getting closer and closer to 0 from the right-hand side, so let's go up here. Here it is. From the right-hand side, I'm getting closer and closer to 0. My y value is approaching what? 1. How about from the left? There's nothing. There's no graph on the left of 0. So this would be 1. This would be does not exist. Okay? There's no graph over there on the left side of 0. The limit at 0 would not exist. Yeah. On the right-hand side, it does. It's 1. Left-hand side, it doesn't exist. At 1, it does not exist. Okay. Number 6. Last one. We're going to talk about the greatest integer function. F of x equals INTX. Okay. Some people call this f of x equals, and they do this symbol here. Some books even put 2 of those things around it. But the greatest integer function, you can graph that on your calculator. There's a way to graph that. If you go to y equals, I don't know why I have 0 here. Go to y equals, you go to math, over to num, it's number 5. Math, num 5. And it's the greatest integer of x. Zoom 6. Yeah, it's the step function. Do you remember this one? Yeah? Kind of weird. Okay, the greatest integer function is, there's an open circle at, wait, no. No, there's a closed circle there. Yeah. There's a circle here at 0, 0, and it goes to 1, and at 1, it jumps up to 1. So the greatest integer function is this. All these steps. Okay? What it is it's saying, what is the greatest integer less than like 1.5? The greatest integer, the biggest number that's less than 1.5 is 1. What's the greatest, less than or equal to? What's the greatest integer less than or equal to 2? That's why it jumps up to 2. And all of the 2.4, 2.5, 2.6, 2.7, all the way up till 3, the greatest integer just below them is 2. Once you get to 3, it jumps up. So that's the way it works. It is a function, though, because it does pass the vertical line test. But they like to ask you limits on this. Okay? So let's do a couple. Let's find the limit of the greatest integer of x as x approaches 1 from the right. The greatest integer function as x approaches 1 from the right? Yeah. So get on your graph. Here's 1. This is, sometimes you can picture like a vertical line. This is the right side, and this is the left side. Okay? And as I'm going on the right side towards 1, then my y value is approaching 1. It actually equals 1 there. All right, let's do the limit as x approaches 1 from the left for the greatest integer function. Okay. So jump on your graph, go towards 1 from the left, and my y value is approaching 0. Okay. And so we say that the limit as x approaches 1 for the greatest integer function does not exist. It doesn't exist there. Yeah, if I ask you what's the limit as x approaches 1/2, any of the ones in between, none of the integers will though, but any of the decimals in between, they'll all approach the same number, right? Yeah.